Okay, so we are starting this new unit. This is Unit F, and the first lesson goes through 6.1 in the textbook, which goes through proportions. So here we have some proportions and we want to solve. What we can do here is a process called cross multiplication. When we cross multiply, uh, well, we only cross multiply when we have a fraction equals a fraction. So if we had something like plus 3 over 2, we would not be able to cross multiply. So we can only cross multiply when we have one fraction equals one fraction. But what we can actually do is we can say, all right, well, 3 times 75 is equal to 5 times x. And so 3 times 75 is going to be 225, and that equals 5x. So if we divide that 225 by 5, we get that x is equal to 45. Also notice that 75 and 15, we multiply this by 15, we multiply this by 15. So then 3 times 15 is 45. Over here, we can do the same thing, and we can cross multiply. So we get 2 times 3x minus 5 is equal to 4 times negative 13. So distributing this in, we get 6x minus 10 is equal to 4 times negative 13 is equal to a negative 52. And so if we add 10 to both sides, we get 6x is equal to negative 42, or x is equal to negative 7. So a lot of fraction work here, a lot of multiplication, but we can also have sort of these application type problems. So here we have a nice application problem. And so what it asks us is that the U.S. Census Bureau surveyed 8,218 schools nationally about their girls' soccer programs. And they found that 270,273 girls participated in a high school soccer program in the 1999-2000 school year. We want to find the ratio of girls soccer players per school to the nearest tenth. So per school. So this would be the ratio of girls to schools. So we found that there were 270,273 girls participating in 8,218 schools. So this nearest tenth is kind of a giveaway that we're going to get a fraction. And so what we want to do is we just want to divide this. So 273 divided by 8218, that gives us 32.9 girls per school. Notice that this ratio is written very much in the same way that we'll have other ratios, so like miles per hour or anything like that. So that's all they wanted there. Next up, we have a twin-jet airplane, has a length of 78 meters and a wingspan of 90 meters. Toy model is made in proportion to the real airplane. If the wingspan of the toy is 36 centimeters, we want to find the length of the toy. So if we have length to width, well, the length of the real airplane is 78 meters. The wingspan is 90 meters. The wingspan of the toy is 36 centimeters. We want to find out how many centimeters the length of the toy is. So yet again, what we can do is we can cross multiply. So notice this function here. We can say that 78 times 36 is equal to 90 times x. So if we divide that by 90, we're going to have our answer. Well, 78 times 36 is 2808. And so we can divide this by 90 to get 31.2 centimeters. And it's centimeters because that's what the wingspan is. So this is meters to centimeters. All right, the next are ratios of size of 3 polygons, getting back to geometry here, and we want to make a conjecture about identifying each type of polygon. So the ratios of the lengths, so 2 to 2 to 3. So if we have, well, these are 3 sides, right? So if we have, we don't know what the rate, we don't know how big they are. But if we have 3 sides, we can say that whatever the common ratio is, we can say that's 2 times that number, 2 times that number, and this is 3 times this number. Well, this is a triangle with 2 sides that are the same, so that is an isosceles triangle. And that's all we're doing here. So for part B, we have 4 sides, and it's all pretty much the same, right? So 3x, 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 3x. No matter what x is, these 4 sides are the same, making this a square. Now these 4 sides change. So we have 4 to 5, 4 to 5. So this would be 4x, 4x, 5x, 5x. So we could say it's a square or just any old parallelogram. And so I'm going to say a parallelogram. We're going to be looking at different types of shapes later. So this is sort of a tricky one there, because these don't necessarily have to be right angles. They could be, 30 degrees there, and then this would be a parallelogram. But we have not talked about parallelograms yet, so don't worry too much. But these two over here, A and B, we have talked about isosceles triangles and squares, and so introducing the ratio of the sides is an important context that you should know. All right, so next up we want to solve these proportions. So yet again, we want to do some cross multiplication. So 15x is equal to 30. So that means that x is equal to 2. Over here, we get 14h is equal to 28. So h is also equal to 2. Here we get 8a is equal to 12 times 14, which is 168. And so if we divide that by 8, we get 21. 5m is equal to 40, so m is equal to 8. Down here we get 360 is equal to 15b. So 360 divided by 15, that just makes it b is equal to 24. 8 times 35 is going to be 280, and that's equal to 28v. Divide both sides by 28, and we get that v is equal to 10. So some simple questions there. And then another word problem, another application. So the ratio of sophomores to juniors in the math club is 2 to 3. So if there are 21 juniors, how many sophomores are in the club? Well, using cross multiplication, we get that 42 is equal to 3x, and if we divide both sides by 3, we get that x is equal to 14. So this is all about proportions, ratios, cross multiplication. So make sure you get some good practice with fractions, multiplication, and a little bit of algebra.